Now that we've seen how to construct frequency distributions for quantitative data, let us consider how to make charts using quantitative data. First, let's consider the histogram. The easy way to remember what a histogram is it's just like the bar chart for categorical data. For quantitative data, we call the equivalent the histogram. The variable of interest, in this case the class limits, we will place on the horizontal axis. And we will then draw rectangles or bars with heights corresponding to the frequency, relative frequency, or percent frequency. As you can see, recall slide 21. Two observations were in the class 50 to 59, and that's why the height of this rectangle is 2. 16 observations were in class 70 to 79, and that's why the height of this rectangle is 16. There are several types of histograms. Some are symmetric. Consider this. The right-hand side is the mirror of the left-hand side. That means that the percent of people above the middle is almost exactly equal to the percent of people with values below the middle. This is the case, for instance, with heights and weights. But not all histograms are symmetric. Consider this. There is a tail to the left, and this is what's called a moderately skewed left histogram. One example is test scores. Most scores would cluster between, 70 to 100%, and there would be fewer with very low scores. What do you guess is the next type of histogram we will consider? What's next is what's called moderately skewed to the right. As you can see, there is a tail to the right. One example is housing values. Why do you think that is so? Please take a moment to consider. Now consider this graph. It has a very long tail to the right. This is what's called highly skewed right. There are very, very few observations that have very high numbers, and most of the rest are in the low or middle ranges. One example is executive salaries. Now let's consider what are called cumulative distributions. Cumulative frequency distributions, cumulative relative frequency distributions, and cumulative percent frequency distributions. Please take a few moments to read the definitions. How do we construct these cumulative distributions? What we do is we add up the frequency distributions from the lowest class to the highest class. And what we do is we add them up cumulatively. Let's refer back to the data in slides 21 and 22. Remember these? These are the frequencies of each class. 2 observations in 50 to 59, 13 in 60 to 69, etc. And these are the frequency distributions. 0.04 in 50 to 59, 0.26 in 60 to 69, or alternatively 4% in 50 to 59 and 26% in 60 to 69. This is how we construct the cumulative distributions. There are 2 observations below 59, below or equal to 59. There are 15 observations below or equal to 69. How do we get that? That's 2 plus 13. Let's go back. 2 plus 13, which is 15. Please take a moment and check for yourself that there are 31 observations less than or equal to 79. How do we get that? 2 plus 13 plus 16, which is 31. Hence, there are 31 observations less than or equal to 79, and hence the cumulative distribution of 79 is equal to 31. Using the same logic, we can construct the cumulative relative frequency distributions. Let's go back to slide 22. 0.04 of the observations are less than or equal to 59. 0.26 of the observations are less than or equal to 69. Hence, the observations that are less than or equal to 69 must be 0.04 plus 0.26 or 0.30. This is exactly this observation. I will leave it to you to see for yourself how to construct the cumulative percent frequency column. Now, what's the next thing we do with this data? We can graph them, right? Because now we know all these values which we can put on the horizontal, and we know these values which we can put on the vertical axis. Such a graph is what's called an ogive, which is simply a graph of a cumulative distribution for any type of cumulative distribution: cumulative frequency, cumulative relative frequency, or cumulative percent frequency. As you can see, for instance, as we said, 4% of the observations are less than or equal to 60. 30% are less than or equal to 69. So this is what the data points would look like. This one and this one. All you do is connect them with a straight line and you get what's called an ogive.